Okay, what I want to do is show you guys a couple of different functions on the calculator that will help you with the binomial probability distribution. Now there's two functions on your calculator. The first one is what we call the binomial PDF, and the arguments here are n, p, and x. Now remember, we say that x follows a binomial distribution with two parameters, n and p. Now what the binomial PDF gives you is the probability that the discrete random variable x is equal to some particular value. Okay, so these two are equivalent. And then the next function is something called the binomial CDF, and the parameters are the same, n, p, and x. However, this function gives a very different value. It gives the probability that x is less than or equal to some value. So let's take this example here. A binomial probability experiment is conducted with the given parameters. Compute the probability of x successes in n trials. So here we say that x follows a binomial with number of trials n equals 11 and probability of success p is 0.5. Okay, so let's first look at this case here. So case number one, if I want to know the probability that x is equal to, I don't know, let's just say 4. Then all I have to do is go over here to my graphing calculator, and I'm going to go to second and then distribution, and then I'm going to arrow up to binomial PDF, and the number of trials is 11, and the probability of success is 0.5, and the value of x we'll say is 4. Okay, now if you don't have the fancy menu here, you can just enter the n, p, and x into your parentheses separated by a comma, because that's essentially what it'll do, is paste it in here and separate it by commas. So now we just hit enter. Okay, and we get 0.1611. So now we can go back over here and .1611. Okay, so just try one more here. What is the probability that x is equal? Remember, we're talking exactly equal to, let's say 7 successes. Okay, so again, we just go back to our binomial distribution. And n, p, and x this time is 7. Enter. And then enter. It looks like it's the very same or almost the same value. Basically what's happening here is these two are so close together that the difference is not going to be on out here until I don't know, maybe the 15th or 20 decimal places out. They'll be very different. Let's try one more. Let's try to change this one here. These two probabilities are not the same, but let's change it. Let's change from 7. Let's maybe say 9. So out of the 11 trials, what is the probability we get exactly 9 successes? Let's see what we get here. So PDF and enter and enter, and we'll change this to 9 and then enter, enter, and enter. Okay, so we get a little different number here. 0269 is the probability. 0.0269. Okay, so that's the first case. Now let's do a couple of examples here where we have x is less than or equal to some value. So actually let's do the one that the problem wants us to do here. So what we're really looking for, this is going to be the probability that x is less than or equal to 4. Now this one will be the CDF. Okay, anytime you want to find less than or equal to some value or greater than, and I'll show you in a second, to find greater than some value we can use the complement. Okay, so let's go back over here, and this time we're going to do the CDF. Okay, number of trials is 11. Probability of success is 0.5. And the x value is 4. Paste. And enter. Okay, so we get 2744. Now essentially what this does is this CDF, what it does is it adds up the probability all the way from x equals 0 up to x equals 4. So this is really like, if you were to write this out, this would really be like the probability that x is equal to 0 plus the probability x is equal to 1 plus the probability x is equal to 2 plus the probability x is equal to 3 plus the probability x is equal to 4. Okay, and then we get that value over here, 2744. Okay. Now, what if we wanted to maybe see the probability of getting x greater than 5? So how would we do that? Okay, so let's say that we want to know getting the number of successes greater than or equal to 5. Now remember, this function only gives you the probability of less than or equal to some number. Okay, but notice something here. We have n equals 11 trials. P is 0.5. And so therefore x can range anywhere from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And we're wanting to know everything x is greater than or equal to 5. So we're wanting to know all of this probability here. Okay? Now, remember, if you add up the probability that x equals 0 plus 1 plus 2 plus 3 plus 4 plus 5, you get 1. Okay, so the total probability is equal to 1. So let's look at it like this. If we say the probability that x is greater than or equal to 5, we can say is the same thing as taking the total probability of 1 and then taking out all of this probability here that's in the green. Okay? Because remember, green plus yellow is equal to 1. And we'll make the plus sign just a little different here. Okay, green plus yellow is equal to 1. So if we take the total probability and then we take out the probability where x is less than or equal to 4, which is the green, so this green probability here is represented by the probability x is less than or equal to 4. Then what we're left with is 5, 6, 7, 8, 9, 10, 11. And remember, this is the binomial CDF. Okay? N, P, and X. Remember, it gives you the probability where the X is less than, right? Less than or equal to some value. That's what that function gives you. It doesn't give you greater, it gives you less than or equal to. Okay? So now all we have to do is just plug in here N, P, and X into our CDF. So we can say 1 minus the distribution CDF. Okay. And we've got that in there. Okay, so we calculated the whole thing here. 72558 is the solution, but remember 2744. We'll just cut it off at 4 decimal places. So this is really okay. So that's how we use the binomial PDF and binomial CDF to easily calculate these probabilities, these binomial probabilities. Okay, so anytime you're asked, remember, anytime you're asked the probability that x is less than or equal to something, you can just use the CDF straight away. Okay, but whenever you're asked to find the probability where x is greater than, you're going to have to use the complement. Okay. Now sometimes you'll be asked things like this: find the probability that x is less than, let's say 10. Well, less than, you have to be careful here. You really want to say that this is the probability that x is less than or equal to 9. So again, you want to pay attention to the equal to sign, and this whole complement bit. So I hope this helps you with the homework when you're doing your homework in terms of the binomial probability distribution.